Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study about ladder friction. Coming to previous sessions, what you have covered before. In previous sessions, we covered the part of the friction, what is the friction, what is the limiting friction, what is limiting friction, and solved problems on friction on horizontal plane and on inclined plane, and also covered on horizontal plane is single body and the double bodies, and also on inclined plane is single body and double body. Here, this topic comes under the portion of applications of friction. So it is very, very important in order to friction applies in the applications of friction. There are various applications are there. One of the application of the friction, there are some applications that are already covered. So certain applications are here we are able to walk because of due to friction. And in automobiles, there is a friction which holds the vehicle comes to rest, or braking the vehicle or reducing the speed because of the friction between the shoes and the plane, between the brake shoes and the plane plate. Here, the ladder friction is one of the application. So ladder friction and also wedge friction. So here, ladder friction means the ladder is nothing but a device which is used for climbing or scaling on the roofs or walls. It consists of two long uproots of wood, iron or rope connected by a number of cross pieces called rungs. So these rungs are as steps. Here the meaning is that here the ladder looks like here. There are two vertical bars which are connected by a horizontal rungs. These are known as the steps. At equal distances, these are the rungs. So these rungs are used for what purpose? Mainly used for climbing purpose, and also here these rungs are used for stepping. So here these rungs are used as steps in order to climb, particularly on the roofs or on the walls for the purpose of painting or for nailing or for electrical repairs, etc. So if we keep this rung in the turn around 90 degrees and slide the wall, here if we just slide the wall, it looks like that, the slide. So there are two spots here on the top edge, and the one is the bottom edge. So this top edge and the bottom edge, when it is in contact with the wall here, this portion with the wall, W is forward at point B. At point A, it is on the floor. It is on the floor. This ladder is in contact. At point B, it is on the wall. At point A, it is on the floor. It is able to stand there because of the friction. Grip friction will be there. So suppose if there is a tendency, this point B, when the person climbs on the wall, here, he stands here. When he stands here, it load acts vertically downwards. Load acts vertically downwards. When the load acts vertically downwards, this point B, tendency of the point B moves downwards. The moment of this point is coming downwards. The coefficient that the friction acts, the frictional force acts in opposite to the direction of the motion of the point B. That's why the frictional force acts upward direction. When the point B is tendency coming downwards, what will happen at the point A? The point A go away from the point A here in this direction. What about friction force? The friction force is always in opposite to the direction of the motion of the body. That's why the friction force acts in this direction, FF. So the normal reaction is always normal to the surface, normal to the point of contact. That's why RW is the normal reaction. And what about normal reaction at point A? It is the point A is normal reaction. The inclination of the ladder here it is considered is alpha. Okay, so these are the four forces are there. One is two normal reactions, another two forces are frictional forces. There are 2 points of contact. Yes, the points of contact at point A with the floor at point B, that is the wall. The downward direction, here it is, the force, one more force is acting vertically downwards, that is the weight of the person which is standing on the rungs of a ladder. Okay, this is what main concept of this ladder friction. These frictional forces and the normal reactions are useful to calculate the coefficient of friction. Alright, now let me describe what is this ladder friction more in detail. Here, consider a ladder A-beam resting on rough ground and leaning against a wall, which is shown in figure. It is leaned against the wall and it is the floor, but both is the rough ground. Now the point is that at point A and point B, there is a rough surfaces. We consider it as a rough surface, then only coefficient of friction exists. If there is smooth surfaces, what will happen to this ladder when it is leaning against the wall and resting on the ground? No, it can't be rest. He can't stay as a rest position because of the smooth surfaces. There is a sliding action takes place at point B and point A and point B also. Then the collapse of the ladder takes place when the person climbs on a wall, when the person climbs on the ladder. Now, these surfaces are, the wall is on rough surface and also floor is also on rough surface. Now, at the upper end of the ladder, okay, the upper end of the ladder tends to slip downwards. The tendency is slipping downwards. Therefore, the direction of the force, the frictional force acts upward direction. Friction between the ladder and the wall FW will be, the direction of the frictional force is in upwards, which is shown in figure. That's what I already described. Now similarly at the lower end, the contact between a point A, contact between the ladder and the floor is point A. The tendency of the ladder, here it is, the tendency of slipping is going towards left direction, going away in this direction. What about direction of the frictional force, which is in opposite to the direction of the motion or movement of the slip? It is in direction opposite to that. If it is the left direction, the tendency of the slip, the frictional force is right direction. And the tendency of the slip is right direction, then what will happen? The frictional force is towards left directions. Okay, here the point is that the ladder, in this case, the ladder is slided in this direction. And if you consider the ladder in the direction of, let me explain it here. If it is in the opposite direction, suppose if the wall is like that, if the wall is in this direction, this is the wall. Okay, the wall is here like that. This is the floor. This is the floor, F and wall. And the ladder is slided like that. If the ladder is like this direction, then what about frictional forces? The frictional force, if we consider the frictional forces, the tendency of at point B, this is the point B and here it is the point A. What about frictional force? The frictional force will be in upward direction at the wall. Yes. And what about frictional force? The tendency, it is in towards the wall. That is the frictional force at the floor. Because at point B, the tendency of the wall at point B is slipping downwards. And the frictional force acts upward direction. Here at point A, the tendency of the wall is towards point, it slips in opposite direction, in this direction, away from the wall. Then frictional force acts towards the wall. Okay. Now, the system is on. Now, what to do, how to calculate, what to apply here? We have to apply equilibrium conditions. The equilibrium, there are two equilibrium conditions we have to apply here. So, what are the equilibrium conditions? Sigma FH equal to 0 and sigma FY equal to 0. Sigma FH equal to 0. That means, what is the equilibrium condition full form? Algebraic sum of all horizontal forces equal to 0 and sigma Fy equal to 0. Algebraic sum of all vertical components of the forces is equal to 0. Why? Because here there is horizontal and vertical forces are there. Okay. Now we have to use these two equilibrium equations in order to calculate the coefficient of friction or frictional forces or limiting friction. Now, one more thing here, it is a note. In the form of the note, it is explained that about described about normal reaction at point A and point B. The normal reaction at the floor will act perpendicular to the floor. Similarly, normal reaction at the wall, that the point B, it always acts perpendicular to the wall. Okay, that's what here at the wall, RW acting perpendicular to the wall, and here RF is also acting perpendicular to the floor. Okay, this is what the description of the ladder friction and how to calculate the frictional forces is very simple. Mainly thing is that we have to know it. One thing, the prerequisite for this, the concepts of the friction and also the knowledge of equilibrium conditions in order to calculate the coefficient of friction. Alright, let us start a problem. Here we considered one problem. We are going to apply what we have studied, whatever derived expressions are described previous, what about ladder friction and how to apply equilibrium conditions. Let us see. Through solving the problem we can understand better always. Let us begin. Here a uniform ladder of length 3.25 meters and weight of the ladder is 250 newtons and weighing 250 newtons is placed against a smooth vertical wall with its lower end 1.25 meters from the wall. The coefficient of friction between the ladder and the floor is 0.3. What is the frictional force acting on the ladder at the point of contact between the ladder and the floor? We want frictional force. Okay, so what is the frictional force acting on the ladder at the point of contact between the ladder and the floor? Now one more thing, show that the ladder will remain in equilibrium in this position. There are two objectives here we have to find out for the given data. So by giving the data, you can understand here the ladder here it is considered, it is leaning in towards the wall like this in towards right direction. Now the point is that it is not mentioned the ladder direction of the ladder leaning against the wall. You can consider this is also like that, is the lean like this also. But one thing, the condition is that the point of contact, okay, is the floor position and here it is, okay, wall position. Okay, you can consider this is also correct, this is also correct. Now we consider in this condition. So let us start understanding to solve the problem by using this condition. Now length of the ladder is 3.25 meters. Yes, it is mentioned here to 3.25 meters. Next, the weight. Here the weight of the ladder they mentioned, that is 250 newtons. Please understand here this 250 newtons from where it is acting. The weight always acts of the body passing through center of gravity. So, by considering this ladder is in rectangular section, the length is 3.25 meters, the weight always acts off of the length of the body, that is the passing through center of gravity. This is 3.25 by 2 distance meters, that is 250 newtons acting. Now distance between the lower end of the ladder and the wall. And one more thing, distance between lower end of the ladder and the wall is 1.25 meters. Now we have to consider, is this 1.25 from here to here or from here to here, which position? Because one thing is very important. The distance of the ladder means the distance point, this point we know. What about another end? Another end point is, this is the point with this line action. This is what we have to consider. Alright. Now, and the coefficient of friction between the ladder and the floor, mu F. That mu F equal to 0.3. F stand for floor. And mu W means coefficient of friction between the wall and the ladder. That is mu W. Now for this case, let us begin. Apply equilibrium conditions. Now before that, we need certain things. Resolving the forces, if we apply the forces vertically, vertical forces, now the vertical force is equal to that RF. Here based on this condition, RF is acting. There what are the forces are vertical forces here? One RF, another one is 250 newtons. Vertical means it can be upward direction and the downward direction also. Now RF is upward direction is positive and 250 newtons acting downwards equal to 0. That is sigma V or FH, sigma FV equal to 0. Vertical force is equal to 0. What is the vertical forces? Upward is considered as a positive and downward is considered as a negative forces. Now that's why RF is upward direction and 250 newtons is downward. That's why negative equal to 0. Then RF equal to 250 newtons. Okay, next. This is like a right angle triangle. Like a right angle triangle. Want to find out what is the BC. By considering here it is the right angle triangle. This distance is 1.25 meters AB and considered as a C here. This is 3.25 meters. What about BC? Now AB whole square equal to hypotenuse square equal to horizontal square plus BC square. Now what is that? We want BC. From that BC, from BC square equal to BC whole square equal to AB whole square minus AC whole square. What about BC? From that BC equal to under square root of AB square minus AC square. Now BC square under square root of AB square. What is the AB value? AB is 3.25 meters square minus this is AB component. And what about AC? That is 1.25 meters. Okay. Now we'll get it BC. That BC is 3 meters. This is 3 meters. Okay. Next, taking the moments, we are going to consider the moments equilibrium also, not only FV and FH. We are going to consider here based on this requirement moment equilibrium. That is, here we are going to apply the moment equilibrium. What is the moment equilibrium here? The moment equilibrium is that now FF into 3 about taking moment equilibrium about point B. About point B we are considering here this point moment equilibrium. This is the point B. What are the forces point B? This RF into distance, line of action, clockwise direction. This is in clockwise. Okay. And what about this direction? It is in counterclockwise. Now one more thing that what about this FF? FF is in always in FF is also here in counterclockwise direction. So algebraic sum of R we can make it moment equilibrium about point B. Clockwise moments equal to counterclockwise moments. Now FF into what is the distance here? This FF into 3. This is a 3 meters perpendicular. FF is the force into perpendicular distance. This point FF into 3. Yes, FF into 3. It is in which direction? Counterclockwise direction. Counterclockwise moments equal to clockwise moments or clockwise moments equal to counterclockwise moments. Plus this 250 into this distance we want. That is 250 newtons into what happens? 1.25 by 2 are considered or what is the distance we want? Now what is that? 0.625. Okay. That equal to clockwise moments. What is the clockwise? This clockwise RF into 1.25. From this we know that RF we know already. What is that? RF equal to 250 newtons into 1.25. That is FF into 3 plus 250 times 0.625. From that FF value can be calculated. What is that? FF equal to 52.1 newtons. This is FF value. FF equal to, that is 52.1 newtons. Okay, next step. That is the first objective. The objective one, that is one. Here asked, what is the frictional force acting on the ladder at the point of contact between the ladder and the floor? The frictional force is FF is calculated, that is 52.1 newtons. Now next one is that equilibrium of the ladder. Here explanation is that the maximum frictional force, the maximum force of friction or frictional force available at the point of contact between the ladder and the floor, that is mu times RF. There is a maximum frictional force, that is mu times RF, that is 0.3, whatever the RF is 250, that is 75 newtons. This is the maximum frictional force. Theoretically we calculated maximum frictional force, that is F equal to mu times RF. But by using equilibrium condition, moment equilibrium, the obtained value is 52.1 value. This 52.1 is less than 75 newtons frictional force. Based on, this is the frictional force based on based on normal reaction calculation. But this is the frictional force we calculate based on normal reaction, but included by using equilibrium condition, the calculated value is 52.1 newtons. This 52.1 is less than the 75 maximum frictional force value. This FF into mu RF gives the maximum frictional force value. That frictional force value is 75 newtons. The calculated is 52.1 newtons. So this 52.1 is less than the value of maximum frictional force. That's why the ladder is in equilibrium conditions. It doesn't move, it doesn't slip. That's what here the meaning is that. So the amount of frictional force available at the point of contact, the maximum frictional force is 75 newtons, is more than the force of friction required for equilibrium. For keeping the equilibrium, we need the frictional force is 52.1, but the maximum frictional force is obtained is 75 newtons. So equilibrium, that is 52.1, is less than 75 newtons. That's why the ladder will remain under equilibrium position. That is what answer about this. That's why why it is application of the friction, concept of the friction. We applied here, we use the ladder, we applied to ladder friction. So we calculated whether the ladder is in equilibrium or not. So with this we calculated how to use equilibrium conditions and calculated here what is the coefficient of frictional force. And also one more very very important objective, we validated that the ladder is in equilibrium position or not. Okay. The next problem, if you let me start with the next problem, is that a ladder 5 meters long rests on a horizontal ground. 5 meters long, rests on a horizontal ground and leans against a smooth vertical wall at an angle of 70 degrees with the horizontal. That is the alpha given, alpha equal to 70 degrees. The weight of the ladder is, again, what is the value of the weight of the ladder is 900 newtons and acts at its middle. The ladder is at the point of sliding when a man weighing 750 newtons. The man weighing 750 newtons stands on a rung 1.5 meters from the bottom of the ladder. Calculate the coefficient of friction between the ladder and the floor. Between the ladder and the floor. Again, frictional force. We have to calculate between the ladder and the floor. But one thing, on this ladder, in previous years, in this ladder, let me explain. They have given there is a person standing at a distance of 1.5 meters from the bottom of the ladder, and the man weight is 75 kgs approximately, that is 750 newtons. But the weight of the ladder is 900 newtons. The weight of the ladder acting where? At the middle of the ladder, and further length of the ladder is 5 meters. That means the weight of the ladder is acting at a distance of 2.5 meters. But the person is standing where? At a distance of 1.5 meters from the bottom of the ladder. But what to be calculated? Again, frictional force, FF. What is the coefficient of friction? Now, based on the given input data, again, this is the diagram is obtained here. This diagram is not given. We have, based on the data, we have drawn the free sketch. The observed free sketch looks like that. The total distance is how much? 5 meters ladder. What is the angle of inclination of the ladder? Is the point B or point here? Point A and point B. It is towards the right direction, is a lean. You can make it again left direction also, nothing wrong. Alright. Now, it is 900 newtons is acting at a distance of the ladder distance, that is 2.5 meters at the top or bottom. And 750 newtons, here this is the point. 750 newtons, this person is acting at a distance of 1.5 meters from the bottom of the ladder. It doesn't say thus giving at the top of the ladder. It is from the bottom of the ladder. Alright. What to be found? Again, frictional force. Again, you have to apply two equilibrium conditions. Sigma FV equal to 0 and sigma M equal to 0. So the given data here, length of the ladder equal to 5 meters. Angle which the ladder makes with the horizontal alpha, that is 70 degree. Weight of the ladder is 900 newtons. That weight of the ladder is considered as W1. Weight of the ladder W1. And weight of the man, that is W2, that is 750 newtons. And the distance between the man and the bottom of the ladder is 1.5 meters. Now, the free body diagram is like that. Normal reactions acts and the frictional force is always towards the wall. Now again, we consider here, apply the vertical equilibrium conditions. The vertical equilibrium condition, that is sigma FV equal to 0. What is sigma FV equal to 0? Algebraic sum of all vertical forces equal to 0 or upward forces equal to downward forces. Now the upward force is considered as a positive and downward forces are considered as a negative. What are the upward forces? Let us find out. This RF is acting upward. Of course, the normal reaction. 750 acting downwards. 900 newtons acting downwards. Now let us begin. RF acting upward forces equal to, what about downward forces? 750 downward plus 900 newtons. That's why it is 1650 newton. That is RF. Normal reaction. The force at the floor. Now, what about the maximum frictional force? That is FF equal to mu times RF. That is mu F times RF. That is FF equal to mu F times RF. That is mu F into 1650. Now we have to find out the taking moments about point B. We have to take the moments point B, apply the equation, and then what will happen here? This RF into what is the distance from here to here? We have to calculate the distance. That distance comes, whatever AC, we know the length of 5. Okay, 5 times. Okay, you can consider it's the 70, here 20 degree, and whatever here 90 degrees. Or 5 cos 70 or 5 times sin 20. That is also alright. Now RF into 5 times 5 sin 20 here, or 5 cos 70 also. If you consider this BC becomes, if you consider vertical, this is 5 times sin 70. This is 5 cos 70. Or if you consider from B point of view, the vision angle, if you consider the B point angle, then it becomes 5 sin 70. It is 5 sin 20. Okay, of course, 5 cos 70 correct. 5 sin 20. And what will happen here? 5 cos 20. That is also here. Now we consider 5 times sin 20. RF into 5 sin 20 equal to, what about FF? The FF into this distance, moment equilibrium, whatever that, 5 cos 20. FF into 5 cos 20 plus 900 times 2.5. Where is the 2.5 distance? This is 900 times 2.5. Again 2.5 meters. 2.5, this distance we want. that is sine 20, 2.5 times sine 20 plus 750 times. What about this distance again? We want about this point, this into this one, that is again sine 20, 3.5 times sine 20. The point is that here clockwise moments equal to anti-clockwise moment. This is anti-clockwise. Here these are left side, it is clockwise direction. Clockwise movements equal to anti-clockwise movements or counterclockwise movement. That's what it is, a moment equilibrium. Now RF into 5 sine 20. What is that RF? We know the value 1650 newtons. Substitute 1650 times 5 sine 20. FF times 5 cos 20 plus known values. Then it becomes, what is the value? FF equal to what? That is mu F times RF. Mu F times 1650. That is mu F times 1650. This time, this is the term, that is mu F times 1650 is the related to frictional force at the floor. 5 cos 20 plus 4875 sine 20. What is the unknown here? The unknown comes, mu F is going to be calculated from this equation. Now, what is the mu F equal to? 0.15 newtons. What they ask here, calculate the coefficient of friction. It is not FF. Sorry, the coefficient of friction, that is mu F, is to be calculated. FF also already calculated. Now, that is FF equal to mu F times RF. If you want FF equal to mu F times RF. What is the mu F here? 0.15. What about RF? That is 1650. Now you will get it. What is the frictional force FF? Here, yes, this, the coefficient of friction, the ladder, between the ladder and the floor, the coefficient of friction is 0.15. So this is very, very important model or very important problem we solved here under two things. When the man is standing, and also one more thing is that the ladder, consider the weight of the ladder, and here it is given angle of inclination. In before previous problem, it is only weight of the ladder is considered. Here, weight of the ladder and also weight of the man which is standing at a distance of 1.5 meters from the bottom of the ladder. Okay, now here the point is that, very important. Here let me summarize what you have considered about ladder friction. In this session, we considered what I described, what is the ladder, what is the use of the ladder in the case of the frictional forces, and when the ladder is leaning against the wall towards the right direction, we considered all the cases and calculated. One is the frictional force and another one is the coefficient of friction. We calculated that there are two problems we solved here. Two problems were solved here. In the first model, we calculated the frictional force when we only considered the weight of the ladder. In the second case, in the second problem, we solved here by considering not only here the weight of the ladder and also weight of the man which is standing. Okay, and here the angle of inclination also considered. Based on these considerations, we calculated the coefficient of friction and frictional forces. Here, if you observe in these two problems very carefully, we considered here the normal reaction forces at the bottom, frictional force and the normal reaction at the floor considerations. Okay, and here we can solve the problem as a practice. If the ladder is leaning towards the left direction wall, yeah, like that, what will happen? For both the cases, you can consider it. It doesn't affect the result. Whatever direction may be, here the consideration is that the point of contact, okay, and the property, the frictional forces and an angle of inclination. It is not the direction of the ladder, which direction, and okay, and also matters angle of inclination. Okay, towards the left or right, leaning against the wall. But you can solve by considering towards the left direction, the ladder is leaning towards left direction on the wall. Then you'll get the same values. Okay, these are the references we followed here. Especially we concentrated in this session the engine mechanics by R.S. Kurmi. Okay, these are the references like Irving, James, Hebler, and Johnston, and also finally this in this is the book you can easily understandable, of course, all the problems, but which you can follow. First, okay, you can follow this book, and also these are the references we followed in this session. With this, we can stop this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.